Good morning. This is a live testing of a 26 inches Insignia LCD TV. Okay guys, I want to discuss the proper way on how to troubleshoot this one. The model number is NS-LT-DVD26. The input voltage of the TV, this is alive now, 100 to 240 volts, frequency 50/60 Hertz. The power consumption of this is 150 watts, made somewhere else. Okay. The symptom of this TV is it can be switched on using the remote control or by pressing the power button on the body of the TV. Okay, you can switch it on. The standby LED light is alive. When you try to switch on using the remote control or by using the power switch on the body of the TV, it got a blue screen. It's a blue screen, it's blank. Then after that, if you try to use some of the buttons on the remote control, nothing will work. Okay. At plug-in, this television now is plugged into an isolation transformer. The current consumption for the meantime is 0.79 amperes. The terminal is plugged into the isolation transformer, so when I measure voltage later on after this discussion, okay, I will be safe. Okay. Before I will do this live testing, okay, yesterday I tried to replace some filter capacitors because this TV is more than I think maybe 15-year-old. So I think the capacitors are, maybe the electrolyte inside are gone or no more or not so many. So what I did is that I use my out of circuit meter. I bring out this electrolytic capacitors. This is the 150 volt capacitor. And these other things, I got around 7 over here. I replace all the electrolytic capacitors on the output. Okay? It's not heavy. It seems it's light. So maybe after using this for 15 years, the electrolyte inside is gone maybe. So as a precaution, okay, if you are not sure if it still works or not, the proper way is to replace it. That's the motto in electronics. If you are not sure if it's still working or not, replace it. It doesn't hurt as long as you have the replacement capacitors. So actually yesterday, I replaced two high voltage capacitors on the primary. They are suspect also because the electrolytic capacitors on the primary, it's just like a bank. You are getting something from it, and the one inside, the electrolyte inside, maybe not too many. So I just replace it. And on the secondary side over here, the one that powers up the mainboard, where the location of the microprocessor is, I replace around, I got 6, 2, 3, 4, 5, 6. I replace 6. Other values are a little bit low, but if you try to weigh it, it seems they are not heavy. Something is wrong inside. So as a precaution, I replace it already. Oh, that's a part of the troubleshooting where the circuit is not alive, right? So it is safe. When I did this yesterday, the LCD TV is not power up, so it's safe. And what I will show you today will be live circuit testing. Live circuit testing. We got two terminals here. Okay, the first terminal, okay, it got 13 terminals, and when the TV was not alive, I tried to check out the supposed to be value. Okay, for terminal number 1, it got 13 terminals. This one, that's alive, so I'm not touching it. Okay, 1 to 13. The number 1 is ground connection. 2 to number 4 got no connection. 5 to 8 will be ground connection. A while ago, while the TV is not alive, I checked the continuity of the ground. I put my tester on the ground and I checked each individual ground, and it sounded. So there's no disconnection on the ground connection. Okay, so we are safe to say that the ground connection got nothing to do with the not working of this TV. Terminal number 5, the voltage should be 24 volts. Number 10 should be 24 volts. Number 11 should be 24 volts. Number 12 should be 24 volts. And number 13 should be 24 volts. These 24 volts are the one lighting up the screen. Okay? LCD, liquid crystal display. The voltage is not too high, but it's a perfect 24 volts DC. So the use of this 24 volt DC from number 9 to number 13, I think these are the one that will power up the LCD screen in front. Okay? I'll discuss terminal number 2. Terminal number 2 is the one at the bottom portion, this one. It got 13 terminals also. So a while ago, while the TV is not alive, I checked the specification. Because the specification, we are lucky, okay? There are some manufacturers in which, beside the terminal output, they put the supposed to be specification. So even though you don't have the schematic, at least you know what you're looking for if you are troubleshooting. Okay? For terminal number 1 and terminal number 2, number 1 is CC Beaky Adjust. I don't know what's Beaky Adjust. The rating is supposed to be 4.13 volts. Number 2, Beaky On. I don't know what's the meaning of that one. I've been troubleshooting for a long time, but I don't know what's Beaky. 5.16 volts. Number 3, the standby. The standby is the one powering up the TV. When you plug in the TV, okay, there should be a standby LED light in front. Okay, when you plug it in, the color of that standby LED is red. Okay, red. So when you try to push this remote control button, it turns green. Okay, the LED light, it turns green. Then the screen will come out. Then if the receiver is good, the video will come out, the sound will come out. But if there is something wrong, okay, like what we are doing now, when I power it on, the screen is just plain blue, no signal, no nothing. Okay, so that's the symptom of the, that's the one we are troubleshooting for it. Terminal number 4 to number 6 for terminal number 2 is ground. Number 7 is the terminal voltage should be 5 volts. Number 8 should be 5 volts. Number 9 should be 5 volts. Number 10 should be ground again. Number 11 should be ground again. Number 12 is 12 volts. And number 12 is 12 volts. These are the required voltages if the receiver is healthy. Okay? A while ago, okay, I checked number 1. Okay, let's go back to terminal number 1. There's nothing magic over here. For terminal number 1, I checked this 24 voltages and this 24 voltages from terminal number 9 to 13. Number 9, the value is 24.11 volts by using my tester. Number 10 is 24.11 again. Number 11 is 24.11. Number 12 is 24.11. and number 13 is 24.03. Okay, I will show you terminal number 13. We are plugged into the isolation transformer. The convenience outlet is on. I switch on the TV. Okay. I know that the TV is on, but not yet working. The standby current using my energy meter is 0.77 amperes now. Okay. If that is zero, the standby voltage is not present, and even the LED light in front of the TV is not working. But for this, it's 0.77 amperes after powering it on. Okay. I will check the output of terminal number 1. Okay. Terminal number 13. This is here. Terminal number 13 is the one at the bottom portion. You see my hand? I'm just using one hand, but I don't want to use the left, because if I am electrocuted, okay, the current will go to my left hand, go to my heart, and I'm dead. If I am not protected, but I am protected because I've got the isolation transformer, okay? And the proper way how to measure is actually just use one hand and you're far away from the circuit board, okay? So you're not touching any metal thing over there. I connected the ground already. The cold ground is the heat sink on the secondary. That's the cold ground. Okay, I will place this red terminal. My tester now is set to DC voltage. Okay, this is automatic digital. My ground connection is connected to the cold ground. Okay, so if I want to measure voltage, I use the red thing here. I will poke this one to any terminal which I want to measure voltage. Okay, I will poke this to terminal number 13. Okay, terminal number 13, the voltage is 24.08. That's fine. You see it? That's a live testing. Terminal number 12, it's still 24.08. So they are alive, right? Terminal number 11, this is the dangerous part of it, but it's not so dangerous. We are on the cold side. Terminal number 11, 24.08. Okay. Terminal number 10, still 24.09. It's almost the same. And I will go with terminal number 9. Terminal number 9, it is 24.09. Okay? So, for output terminal number 1, okay, for live testing, okay, 13 is 24.03. The schematic there or the marking there, it should be 24 volts. So that's fine, right? The second one is 24.11. It says supposed to be 24. That's fine. 24.11. The next one again, the marking there, it should be 24 volts. So that's fine. 24.11, 24 volts, 24.11. So for the last 5 terminals on the first output terminal over here, all the voltages are fine. Okay, so it seems our power supply is correct. No, there's nothing wrong with our power supply. But how come the TV is not working? Okay, that's the one we are looking for, okay? So on the first terminal, I've done the live testing already, okay? So I will go with terminal number 2. Terminal number 2, the bottom portion, this one, I will use a non-conductor thing to shooting over here. 13 terminal. Number 1, the reading should be 4.13. Number 2 should be 5.16. Number 3 is the standby voltage. Okay. Number 7 should be 5 volts. 8 is 5 volts. 9 is 5 volts. Number 12 should be 12 volts. Number 13 should be 5 volts. Okay, before I will measure the live voltages on terminal number 2, I want to discuss what's the significance of these markings over here. These 5 volts. 5 volts is the power supply for microprocessors. This one. The one on the main board. The one they are doing at the silicon technology. Okay. Power supply for microcomputers or microprocessors for electronic TVs. The one that uses electronic. It's 5 volts. So supposed to be these 5 volts here. These are the one that will power up the microprocessors there. The only problem on the main board, designers now design one IC in which the different modules are incorporated all over there. So actually you could not troubleshoot like the audio circuit separately or the video circuit separately. It's all incorporated on the microprocessor. And for that microprocessor to malfunction, if the supply voltage of that microprocessor is nothing or low, okay, it will not work correctly. So let's verify if these 5 volts are okay. And this 12 volts here, 12 volts maybe the power supply for the audio circuit, and the other 12 volts may be the power supply for the video circuit. But we could not, what they call this, segregate the audio circuit, video circuit, and other processors from the main board because in San Jose, in the silicon technology, they try to manufacture an IC already in which the audio, video, and other processors are incorporated into one IC. So actually, in digital circuits, there's nothing you could do to troubleshoot it. Actually, the proper troubleshooting, if something's malfunctioning on the microprocessor, is to replace the main board. But for the meantime, as a show of how to properly troubleshoot this one, I will show you, okay? I will now try to measure the correct output voltages for terminal number 2, okay? This is live. Okay? I will go with terminal number 13. 13, this bottom portion. It should measure 12 volts. Okay, hold on. Okay. What comes out for 13 and 12 are both 11.78. And these 5 volts here, I will go to terminal number 7. Oh, hold on. They are all zeros now, guys. But a while ago, while I was not yet on live video, I measured 13. This 12 volt measures 11.78, a little bit low. This number 12 is supposed to be 12 volts. It's also, I measured 11.78. And this 9 volt here, no, terminal 9 to 7, they are all supposed to be 5 volts. What I measure is 5.86 volts. And supposed to be, what's the significance of this 5.86 compared to 5 volts? Meaning, if the receiver is supposed to be drawing current, okay, this 5 volts should go to 5 volts or near 9 volts, but not over 9 volts. So meaning to say, the microprocessor board is not drawing current. That's why it's malfunctioning, okay? Even this 12 volt for the meantime is 11.78, it's not present now. A while ago, number 1, B key adjust is 4.13, B key on is 5.16, and the standby is 3.3 volts. A while ago, while I was not yet on video. But now, if I will try to measure it. They are all zeros now. So, meaning to say, there's a problem with the main board, the microprocessor board, the one over here. The microprocessor board or the main board is where the board, what you call this, try to do the proper thing on how to bring out the audio, video, or something like that. So if this one is not drawing current, because as I notice it, it's not drawing current from this. Even this 5 volt here is gone. See? It's gone. It's gone. So it's either that there is still a problem on the switch mode power supply, or the problem on the mainboard is that if there's something wrong with the mainboard, okay, it will try to load down the switch mode power supply. It will try to load down. It will kill any voltage that you're supplying to it. Because for the meantime, what's coming out is 0. Okay? So, it's still a double guess. It's either that the switch mode power supply, there's something wrong with it, okay? Or the microprocessor board or the main board is not drawing current, or there's something wrong with it. It is sick, that's why it's not drawing current from the switch mode power supply. Okay guys, we have not